So we solved this question, right? We solved this question using the concepts that we have learned in motion in a plane, right? Motion in a motion in a plane. So now what we'll do is we'll try to solve the same question using law of conservation of mechanical energy, according to which the total mechanical energy of the ball should be conserved during its entire motion. Now, at the highest point, the vertical velocity becomes zero and the kinetic energy corresponds only to the horizontal motion. So, if you consider A to be the highest point here, at A, we can say that the vertical motion represented by Vy at A will be equal to 0, whereas the horizontal motion at A, which is represented by Vx at A, would be equal to V into cos theta, right? Okay, now if you want, let me just try to give you a recap one more time. So we know that when an object is projected at angle theta, it can be resolved into two components, one in the horizontal component, the other in the vertical direction, the vertical component. The horizontal motion is one in which the acceleration is zero, it's a uniform motion, which means the horizontal component of this projectile will have a constant nature throughout. The magnitude doesn't vary. But the vertical motion, which is supposed to go like this, that will reduce in magnitude. That will reduce in magnitude and will become zero here. After that, the direction will reverse and would increase in magnitude and will attain the same velocity as it was projected with. Okay. So that's what happens in projectile motion. And at the highest point of the flight, the vertical component of the velocity will become zero. Okay, so we have discussed this much. Now let us see how to apply law of conservation of mechanical energy. So we will first what we'll do is we'll just try to mark 3 points here. One, which is O, A, and B. O represents the point of launch, A represents the highest point, and B represents the landing site. Let us try to spend some time and understand the variation in kinetic and potential energy throughout this motion. See, at the launch point, the total energy is mostly kinetic, as h is equal to 0, and potential energy will correspondingly be equal to 0, which means at O, kinetic energy at O kinetic energy at O would be equal to half mu square and potential energy would be equal to 0. At the highest point, at A, the vertical velocity becomes 0, Vy becomes 0, and therefore kinetic energy at A would be equal to half m into ux square. And the potential energy is maximum. So potential energy is A is not equal to 0. My bad. This is PE maximum. PE maximum. At the landing point, the projectile regains its initial kinetic energy and potential energy is 0, which otherwise means the complete kinetic energy here would be, the complete kinetic energy here at this point would be regained at B again. Okay? Alright. Now, since that you understand this concept, let us try to apply conservation of mechanical energy between the points O and A. So we can say that mechanical energy has to remain constant throughout. So mechanical energy from point 0 to A means mechanical energy at point O should be equal to mechanical energy at point A. What is mechanical energy at point O? It is kinetic energy at O plus potential energy at O. What is mechanical energy at point A? It is kinetic energy at A plus potential energy at A. And we just discussed before that potential energy at O is equal to 0. And we also discuss that potential energy at A is the maximum value where H is H max, right? And kinetic energy at O, let us assume that to be E, and let us say kinetic energy at A as EA. Therefore, we can write that E is equal to EA plus mg into H max. Okay. Now, for a projectile, we know that the maximum height is h is equal to u square sine square theta by 2g. And if the maximum project, if sorry, and if the height at the maximum, sorry, if the maximum height is known, what can we do? What we can do is we can bring in this h max into this equation over here. E is equal to EA plus mg into h max. Therefore, I can write that. Therefore, I can write that E is equal to EA plus m into g into, instead of h max, u square sine square theta by 2g. Now, if you observe closely, g by g is 1. Okay. And I'll write m into u square, right? M into u square by 2 as one common term. And then into sine square theta. Theta in this case is 60 degrees. Sine 60 is root 3 by 2. Therefore, sine square 60 would be equal to 3 by 4, right? So sine square theta would be equal to 3 by 4. So this equation becomes E is equal to EA plus, what is mu square by 2? It is the initial kinetic energy E. So that becomes EA plus E into sine square 60 is 3 by 4. And if we bring up E 3 by 4 to the LHS, what we have is E minus 3 by 4E is equal to EA. And therefore, 4E minus 3E is E. E by 4 is equal to EA. Or what is EA? EA is kinetic energy at the highest point is equal to E by 4. So just an alternative way of looking at the question. Perhaps this is the most correct way if you're trying to look, if you're trying to go chapter wise and topic wise, because right now we're discussing work energy and power. So I used law of conservation of mechanical energy to solve this, and earlier we used projectile motion. Okay, anyway, all right, now that's it with this question. Moving on to the next one.